Hello and welcome back. I hope you enjoyed those segments. Now it's time for our math challenge. So let's go ahead and let's dive into this one. And this one's called the slippery slope. So let's take a look at what's going on here. So first things first, we can see that we've got a circle here. Okay. And on this circle, we have identified that there are 3 points. Okay. Points A and B and point C. Okay. And notice that they are inscribed on the circle, meaning that the points are on the circle itself. And between A and B, we see that there is a line, L1. Okay, there's a line that is passing through these 2 points, A and B. So this will be given to you. All right, you will be given A and B, and then you can derive what the line is that's passing through the circle. And what we want to find in this problem is this point C, where a parallel line has been translated such that it only passes through 1 point on the circle. So we can also see that the origin is at the center of the circle, and we're given some value r, okay, which is the radius from the center out to the circle itself. And of course, this is in Cartesian coordinates with our x and y, okay. And our problem, again, is given a line that's passing through A and B on a circle. Can you find a single point C on that circle that a parallel line passes through? Okay, so L2 is our parallel line that passes through this point C. Okay, a single point. All right, and just as a quick example of one possible scenario. So imagine that point A is at -3 and 0, and point B is at 3 and 0. So here I know that the radius is 3. Okay? So a parallel line that passes through a single point would be up here at 3. Okay? Up here at 3. And this is something that we, 0 and 3, or 0 and -3 could be another solution. Okay? But here we can see that I'm just sliding this line up until it touches a single point on the circle. Okay, it's tangent to the circle. So for our problem, I'm going to propose 2. So I'm going to propose P1. This is a little bit easier, and P2. Okay, so these are 2 different scenarios where I want you to find C. So here we have A equals 0 and 5. B equals -5 and 0. Okay, so this line is very similar to this one that I've drawn here. In fact, this P1 is based off of this that we see here. And I want you to find C for these values. And then a different scenario. Here we have A equals 3, 4, and B is 4, 3. Okay, so those 2 points are going to be over here somewhere. Okay, and I want to know what is that point C that a parallel line translated will pass through. Okay, so I hope that is clear. Let's go ahead. We're going to jump into our questions for this segment. So don't go anywhere. We'll be right back. Hello and welcome to our slippery slope solution. So you remember when we left off, we had a circle. And on this circle, we had 3 points, okay? A, B, and C. C would be somewhere here. And each of these points is inscribed on some circle, okay? And we were given points on this circle, we know that there's going to be a line drawn between the points on the circle, A and B. Okay, so we get some first line, that's line L1. And we wanted to know if we translated this line up or down, okay? If we translated it, could we find the point, the single point at which the line touches the circle, okay? So again, we want to find the point at which the line is tangent to the circle. It passes through the circle at only one point, this point C. Okay, and so let's talk about the 2 problems here. So you remember I gave you P1 and P2, and I said P1 is the easier one, P2 is the hard one. So P1, we can actually solve this by thinking logically and using Pythagoras' theorem, okay? So let's start with P1. So P1 says that A is at 0 and 5, and B is at 0 and -5. Or sorry, -5 and 0. And we can draw that line. Okay. So, I know that I can draw, I just want to look at parallel lines, okay? And I can place that parallel line anywhere. So I'm going to place it first, going through the center. And I'm going to come up with an equation for this line, okay? And I know that I can get a slope of a line by taking the y-coordinates of one point, the y-coordinates of both points, the x-coordinates of both points, and dividing the differences, okay? So m of y of A minus y of B over x of A minus x of B is going to give me the slope of this line. Well, y of A is 5 minus 0, okay, y of B. And x of A is -5. Oh, sorry, that's 0 minus -5. So we end up m is 5 over 5, which is equal to 1. Okay, so we have m. Now we know that the equation of a line is equal to y x times m plus b. Okay? And when it passes through the origin, we can disregard b. And we know that m equals 1. So y is actually equal to x here. Okay, y is equal to x. And that is going to help us figure out where this point should go. Because we know that y is equal to x, it becomes more clear where this point will actually be. And in fact, something interesting is if we take the inverse of this, say that we take y equals -1 over x, this will give us the orthogonal line. And, oh, is that right? Oh, that's not. Is it? Let's see. I think that might be orthogonal. Let's make sure. So, y is equal to 1 over x. As we get small, we get very big. No, that doesn't make sense. Should just be -x. Okay? Oh, it's 1 over 1 -x, that's right. Yeah. This is our second line here, okay? This is our perpendicular line. So maybe I'll label these. So this is L1, L1, this will be L1 perpendicular. L1 perpendicular. Okay. And what we're going to do next is we are going to recognize that this point here is going to have equal components. Okay, it's going to have an equal x and y component. Okay, and that comes out of the fact that the x and y, whenever x increases by 1, y will increase by 1. Okay, whenever x increases by 2, y will increase by 2. So they are equivalent. So the two components should be equal. Okay? And if we know that x is going to equal y, all right? We know that x is going to equal y. We can use Pythagoras' theorem here. Okay? So let's just say that. So y is equal to x. Okay? We know that this angle from Pythagoras' theorem will be 45 degrees. And of course, this is r. And so we can actually determine what x and y should be for this point here. It's going to end up being, from Pythagoras' theorem, we have r squared over 2 square root is equal to x, which is equal to y. And that is going to give us, 5 squared over 2, which is equal to 5 over square root 2. It's equal to x. So I know that for c down here, I already have my two coordinates now. I know that c is going to be, the x is going to be here, the y is going to be here. And I know that the x is a negative number, so I can just put negative 5 over square root 2. And y will be a positive number, 5 over square root 2. Okay. All right, so that one was pretty tricky, but if you thought about it, you figured it out, you can give yourself a pat on the back. P2, believe it or not, is even more difficult. But I'll show you how we can solve P2. So to solve P2, this one's a little bit trickier because we are going to use some derivation, okay? We actually are going to take the derivative, or at least that's what I did. So I won't show you how exactly I derived this. Maybe we can post it somewhere. But we know that given some slope m, okay, given some slope m, and the radius of the circle r, okay, we can determine what the x value should be for any point, okay, for any point. We can determine what the x value will be for some line where it intersects the circle at a single point, okay? All right, so this, I've already derived this. You can derive it yourself as well if you'd like. To do so, you need to, what did we do? You have to determine the derivative of a circle and a line. We'll show it later. Anyways, just trust me that we can use this equation for now. All right, so we have these 2 points here. So let's first find m. So m is going to be, again, it's ya over minus yd. So 4 minus 3 over 3 minus 4. Okay. double check that, make sure that we're correct. 4, yes. 3, yes. 4, yes. 3, yes. Okay. So m is going to equal 1. Or, sorry, negative 1. Okay. So m is equal to negative 1 here. M is equal to negative 1. And actually, if we drew this circle, what we would see, is we would see one point here and another point here. Okay? And actually, I already have an idea of what this solution will be, because m is equal to negative 1. So this is actually going to be fairly simple as well. We're going to know that c, if we remember from last time, if we take the perpendicular, it's just going to be m equals 1. Okay? So we know that the line is going to be the same. It's just going to be perpendicular to our previous line. And so it's going to end up going right here, and it's going to be the same. It's actually going to be 5 over square root 2 and 5 over square root 2. So there you go. Those are your two solutions to our slippery slope problem. I hope that you enjoyed. I hope that you found it insightful. You can try some different points using this equation to figure out what your x component should be. And yeah, this is the precursor to calculus. So yeah.